Hi, I'm Ned and I make games. This video is from my live stream over on twitch.tv/nedmakesgames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, hi everybody. Let's go ahead and get started. I hope you've all had a great day so far, and yeah, half of the week. Mine hasn't been too bad. Got some stuff done this afternoon, so I'm happy about that. Oh, and I do want to apologize. Somebody has decided to mow grass like right outside my window, so if you can hear that. Anyway, let's so tonight I want to go ahead and work on some stuff for next week's video, which my patrons just voted that they'd like to see more of that SDF or assigned distance field stuff. Like a couple weeks ago we did the line segment, and so now we're going to do different kinds of squares. Well, squares and rectangles, and if I have time, might look into like rounding their corners and stuff. Might be kind of fun. Okay, but the first place to look when you want to get into SDFs for sure is to look at Inigo Quilez's stuff, which I'm trying to pull up the page right now. He's done a lot of work with SDFs, so it's a good place to start if you're interested in it. But so I'm gonna try, well, I guess first we'll start with this normal axis aligned box in the shader graph and make sure that works, and then after that I'm gonna try to do this one where you can rotate the box. The only problem with this math is that it's not super well documented, so I don't really know what each of these variables do, and I don't know like how these functions were derived. They're also written in CG, which is different than the HLSL that Unity shaders are written in, but it's not that difficult to translate. Oh, hi Mad Science. Thanks for stopping by. How's your day been so far? So that's my plan. Trying to decide, it might be easier just to do like a custom function for now, and then once we've figured all this out, we can translate that relatively easily into a shader graph. No sleep and fasting in construction? Wow. Sounds like a difficult day, but... Oh, okay. Game development and a construction worker. It's a good, well, quite different. Because one is like all physical labor and then the other one is programming, but I guess that's a good variety. Okay, yeah, so let's make a folder for shaders, and then I'll just create... Oh no, I don't want another folder. Oh right, we have to do this in Windows because you can't create HLSL files directly through Unity. So let's just call this excuse me, box SDF.HLSL. Yeah, that's okay. Okay. Oh yeah, and it won't show up. There's this funny thing with C# projects in Unity where they won't show up unless there's an actual C# file. So for instance, if I tried to look in here right now, you can see that there's no solution or no project for my Unity scripts. But if I just need to create like some dummy script that doesn't actually do anything, and now it will show up. So reload. Okay, and yeah, now our HLSL file shows up as well. So we'll start off with a good old if not defined block, just to make sure that the shader graph doesn't include this twice. So box SDF included, and then the next line you actually define it. Then at the end of the file you'll end it with the end if. Okay, so let's make okay, I'll just call this AABB box SDF, and that just means axis aligned box, so it's like has straight edges on the X and Y axis. And according to these functions, the formula is relatively simple. So what it does, so this P is the position I know of like in world space that we want to get the distance to the box from, and then maybe this B is, I'm not sure what the B is. It could be, so it's just 1 point, so it could be the center, but then how do you get, it's probably the dimensions centered on 0, 0. I think that's what it is. Let's see. Yeah, let's just see how this function works, and then we can add things to it. So in order to translate this from CG to HLSL, you pretty much just have to change this vector2 to a float2, and I think all this works fine. So now let's add our shader graph function, which you just have to add the float suffix. Okay, and so we'll also take in the input point, and I think this is dimensions. I'll just call it B for now, and we can change that. And then out, float, distance. Okay, oh right, this should be capital. And I actually think I'll just call this out. Okay, I just realized that, okay, so the AA is axis aligned, and then the BB is bounding box. So right now I'm calling it axis aligned bounding box SDF. So I guess we really don't need the two B's there. Okay, so in. So that's all we have to do to get this compatible with the shader graph. And so let's just create an unlit shader. Oh, here. For some reason I always have a hard time finding the dialogue. Should probably have made this yeah, let's remake this as a a subgraph so we can color it in different ways. All right. So first we'll have the custom function. We'll take our SDF file. And now it's going to complain that it doesn't have the right inputs, but we can fix that pretty easily. Okay, and so for the input, I'll just give it the world position. Okay, so interesting. Huh, what does Y do? So X seems to be the size, and Y should be... It did say it was a vector 2, right? Oh. Yeah, it's supposed to be, but I did the argument wrong. Okay, that is better. Yeah, so, okay, so that D is the dimensions. Okay. And I guess let's set up a simple scene. We don't need this sample scene. Well, I guess I'm just going to name it test, so that's not that much different. Okay, so let's just have a plane. Yeah, I guess the name is fine. And we'll just put this... aligned in front of the camera. Oh, where'd it go? Oh, okay. Yeah, it was culled. So now we can give it a material with our new shader graph. So if you missed stuff, you're plotting data, but anyway, is this Inigo's functions? His videos document some of the functions, right? Yeah, it is Inigo Quillez's functions. I might change some of them, like I want to give an offset to this, but we'll see. Yeah, I have watched some of his videos, but I actually haven't watched the one on the box, so. But also, why magic code comments are must. Yeah, that would be my only criticism of them, is that, yeah, they are kind of hard to figure out. They're not very descriptive. Like the variable names and stuff, but I mean, still. How's my day going? It's gone pretty well. I got a lot done this afternoon, so I'm pretty happy, but this morning was a bit of a wash, but oh well. Thanks for asking. Okay, I guess this will be for this one, so AA box SDF. Not really sure if we're gonna keep this one around, but we'll see. Even rockets take off slow. That's very true. Okay, so why does my shader graph not show up there? Did I forget to save it? Oh, it's because this is just a sub shader. So I need to create an actual shader graph. I kind of want to get my rainbow shader graph from my other function. Let's not worry about that, because it'll probably be easier to test if I just do something simple. And oh, is it? Oh, okay. Yeah, I kind of messed or did this wrong. This position should also just be an input. And then we'll feed that into the custom function. And I kind of want this, like, you could say that you could just include this custom function in your shader graph instead of routing it through a sub function like this. But I think I'm probably going to change this to just be natively in the shader graph and use all the math nodes, just because I think people would rather work with that in their project. So having it in a subgraph makes it easier to switch that out in the future. Okay, so let's get world position into the input, and then yeah, we'll have a dimensions property here. All right, and now we can add that to the material. Okay, so let's set up the camera so it looks at this plane a little better. Oops. And I'll just make it orthographic. I don't want it to fill up the entire screen. That's good enough. Hi, Soundy. How are you doing tonight? Okay, so now we've got a nice little point, but we can easily add dimensions to make all different types of shapes. So one thing I'd like to do here is, okay, well, first of all, what am I trying to say? Oh, okay, yeah, first of all, it's like bound always to the center position. So I'd like to have an offset. And second, I kind of want this to be like an outline of a box instead of it to be filled in. And we can do both pretty easily. Well, good to hear. I'm doing pretty well too. Like I said, I've got quite a bit done this afternoon, so I'm happy about that. Okay, so first let's take care of the outline bit. So the cool thing about SDFs is that if you're inside of a shape, the distance is negative. So you can do that to shade the inside of an object different than the outside. But since I want to draw an outline, I'll just set this to be absolute. And then we can use a smooth step and have something like, I don't know, thickness and smoothness. Let's set this to something. Udor Sebastian Yogsvit, Sebastian Logsvit on SDFs. Tons of shared toy stuff which boggles the mind on the subject too. Yeah, I know. It's really interesting to look at all that stuff. I actually haven't seen Sebastian's video on it, so I'll have to go check that out. Yeah, they're really fun to play with. They're one of my favorite things about shaders and graphics programming in general. What am I trying to do? Oh, add. So I want to add the smooth property to the thickness, and this will be the second edge to our smooth step node, and the first edge will just be the thickness property itself. Okay, so let's see how that looks in Unity. Did I not? Oh, okay, I didn't feed this into the output. That would be a problem. Okay, so now it's kind of working. Although, yeah, the smoothness was negative, so it was inverting the color. Yeah, it looks pretty good. It's interesting how, as you make it thicker, it automatically rounds the edges. Wonder how difficult it would be to have an SDF that kept crisp edges. I don't think Inigo has something on that, so I'll have to try and see. Might try it out if we have time. But, okay. So what I want to do, I want to be able to use my mouse to draw rectangles. So I think I'd like to be able to specify like a point A and a point B and then draw a rectangle between that. So, first off, we need to be able to specify an offset to our box SDF, which shouldn't be too difficult. Let's go back into here. Okay, so we know this B is the dimensions. So I think I'll go ahead and change this variable. And then we want to have an offset. And I don't think this is going to be difficult to do at all. I think all I have to do is subtract this from P. But I guess we'll find out in just a moment. Okay, let's change this to match dimensions. Yeah, esoteric variable names are my fave. Yeah, that's would be my one criticism of Inigo's stuff, but again, I can't complain too much because he has such a wealth of knowledge that he's provided for free, but and offset. Okay, so it's still having an error. No matching two parameter function. Did I not save the variable? Oh, right. It's complaining here because I didn't update this stuff. Okay, and now if we add an offset property and then route that in here, it should update. I'm going to rename this to just be draw rectangle by corners. Okay, so now I want to just test this offset. So let's just do it like this for now. And now if I... Okay, yeah, that worked. Great. Yeah, I was hoping that would be an easy fix. No comments, bad variable names. That's like saying, I'll solve the world's energy crisis, but only if no one ever eats soy sauce on the rice again. Yeah, that's kind of a good analogy. Yeah, like I was looking through some of these, and it's kind of like half the challenge is well, I guess most people don't have this issue because they're not trying to like teach how to make them, but for me, I need to like decipher all these variables and try to derive the function to put in my video. So Oh, is that like... Sorry, I didn't catch the reference, but... Okay, so... Yeah, so this works pretty good. I guess I should save this graph how it is. In case I need it. Probably for a demonstration. Let's do draw, rect, centered. And then I want to make an edit of it that instead of giving a dimension and an offset, will give 2 points, and then it will draw a rectangle between them. So, point A. Let's. I know I'm going to want to do this in C#, so I'll go ahead and I'm going to want to set it from C#. I mean, so I'll go ahead and give it a reference. All right, and then maybe so we get something here that actually makes sense. I'll just set these to like, I don't know, 0.1. Because it's a lot easier to make a shader graph if you get immediate feedback from the preview nodes. Okay, so we can delete that. So the dimensions here is going to just be the distance between these points. Or their difference. Oops. So we'll subtract A from B, and then I guess we need to take the absolute value of this, and that will be the dimensions, and then the offset is so it's like half of this or something. So okay, so if this point, let's just take the x component. So if A is at like 3 and then B is at 1, then we want, yeah, so it's their average as the center, which makes sense. So we take, yeah, the difference between them and then just divide it by 2. Okay, yeah, which is 0 in this case. Okay, so something isn't right because if I increase by moving point B, it shouldn't like scale it outwards. Oh yeah, this, okay, I think, yeah, this isn't the average. This is like, I don't know, half the distance between them. So to find the average, I obviously need to add them. Yeah, it has been a long day, so excuse some slight math errors. Okay, so now if we mess with this. Oh. That's not quite right either. So what am I doing wrong? Because when I'm changing the second point, it's scaling the, like, both sides of the SDF. I know it's a should be something simple. I just want to find like the center of this, which should be, I would think, the average of the points, but maybe it will come to me. Let's I'll move on to the C# script for now. Right. Draw, or I'll set points. It actually had something similar in my other project, so I might just grab those scripts. Real quick. Okay, here it is. Right, I guess I should delete that set point now, but I'd like to make something that's kind of generic out of this. This script did the triangle scene in my draw lines video, so I'd like to just make it generic so it can also draw like a polygon with an arbitrary number of points. Oh yeah, this one just continually set something to the mouse, so I'll leave that around for now. Oh yeah, and it's complaining because I don't have support for Unity's second input system, but I don't really want to download it now, so I'm gonna comment that out. Oh, okay, now it's saying that all branches don't return a value, which is valid. Okay, so yeah, let's open the set points, and I'll just change the name to match. So I just need to give it a field that tells it how many points are in this polygon. Oops. Although I guess it already knows because I have this array of point property names. Okay, so yeah, when I press left button, it goes to the next point. Okay, actually, yeah, this already works. I don't have to change anything because when I press it, it sets the vector. And then when I lift the mouse button, it moves on to the next point. So yeah, that's already good to go. Let's create a control game object to place this. I can find the L key. Okay, did I... Oh, I didn't save the file. And now it needs our material. Okay. Point A and point B. Okay, so let's see how this looks. So it doesn't match, which we kind of already knew. Yeah, it seems like it's scaling too much. Okay, so let's think about it. So like I said, if I had... trying to think, how do I do math on stream? Normally I'd write it out. Fascinating to see such beauty derived from raw math. I think that is half the fun of SDFs. Alright, so anyway, so like if we had a point, I don't know, 3, to say A equals 3, 1, and then B equals -1, -1, then what I'd want, I can tell the dimensions should be 4, and then the center should be, or 4, 2. And the center, yeah, let's go. I think the center and offset are the same thing. Should be something like 1. Oh, I wonder, maybe this is, okay, maybe this isn't the dimensions, it's actually like the, I don't know what you call it for a rectangle, but it's actually the radius. or like the half dimension. But anyway, so I guess we can figure this or complete this thought experiment. So that should be 0. So if I just did something like this, would that fix it? Yeah, that was the problem. Okay. So yeah, again, yeah, it's not commented, so it's hard to tell. Okay, well, I'm glad I didn't spend too much time trying to figure out the math on that. But anyway, so now we can draw a rectangle just by dragging around on the screen. It's kind of fun. Okay, so before I move on, I think... Oh, I should have done this in the other shader, but I'd like to make it a little prettier by just giving a way that we can interpolate between 2 colors. So line color and background color. Okay, so in order to do that, we need to saturate this first. And then I can do an interpolate, or you could do a blend node, but in overwrite mode would do the same thing as this. Okay, so at 0, which is on the outline, we want the line color, so that would go first, and then the background. Okay, and now let's move that over to our other shader graph. I mean, it's pretty simple. I don't really need to copy and paste, but saves a few seconds, I guess. Okay, so now in our material, we can change the line color. I think I'll just kind of make them off-white. But yeah, I guess this isn't super important for right now, but okay, so we've got this working. Next, I should see how we can draw yeah, a rotated box. So looking at this math, seems here you get the length between the points. Although, yeah, I don't know what A and B are, which is confusing me, because I don't really... Yeah, I don't know how you define the angle. B before was like the half dimensions. Yeah, see, I don't really know what it is. But so anyway, you take the length between them, and then you... Okay, so you're normalizing the distance between them, basically. And then here you subtract the average of them. Kind of what we did to let this be offset. So maybe here you are... Yeah, so maybe this... In this version, he does use 2 points, but I don't know how that would make it rotate. Maybe this TH stands for theta, or the angle between them? I don't know. I was thinking it was thickness, but that wouldn't really make sense. So yeah, probably that's the angle. But anyway, so you subtract the input point from the average of point A and B. And then this our mat2 stands for a 2x2 matrix. So you're doing a 2x2 matrix multiplication with this Q point, which is probably where the rotation happens. And then, so then you take the absolute value of Q, and subtract the length and the angle, and then halved. And okay, so then you take the length of the maximum of this Q vector and 0. So, okay, so basically you're taking the, oh yeah, so you're basically bounding this Q vector to be positive, or each component on it to be positive. Plus so now you're clamping. Okay, so then you add the X and Y components of Q, taking the max of those, and then making sure that both are greater than 0. Okay, so yeah, I don't really know what this math is doing, but I assume it'll come a little bit more clear when we figure out exactly what each of these variables do. Okay, so let's do, guess I'll borrow the oriented box. I might change, well, depending on what A and B means, I might change this to use 2 points instead of dimensions and offset, just so that they're identical, because I would like these functions to both either be specified in the corner points or dimensions, but and then float theta or whatever th is. Hi NTT, good evening. How are you doing tonight? Okay, so let's copy this over, and we'll have to change a few things to get it to work in HLSL. Mostly we've got to change these vector 2s to float 2s, and then we've got to change this match 2 to float 2 by 2. I think everything else will work. I'm assuming that he wants to multiply this vector, or this matrix, which means he'd have to use the mul operator and not the star, or the mul function and not the star operator. Oh, good to hear. You're doing well. Oh, thanks. Great work on the blend video. Yeah, thank you. That one was I think you were here when I was working on it, but yeah, that was a lot of fun to put together. But yeah, I'm doing pretty good. I've got quite a bit done this afternoon, so I'm feeling pretty motivated to finish this up. Declared identifier. Oh right, I forgot to change that. So oriented box SDF. Oh, okay, this should be a float return value, not void. Okay, so now everything's fixed. So let's make a wrapper function to make this available in the shader graph. And again, I'm just going to copy A, B, and whatever TH is. Okay, and now let's make another subgraph to work with this. Where is it? Okay, so this is oriented box SDF. Okay, so we can start with a custom function, and we'll grab the SDF file. All right, so it has the input point and then the A, B, and pH variables, which I think are 2 points and then the angle to rotate, but we'll see. And then output, and let's just feed this here. Okay. So now I just need to make properties to feed into there. I guess I'm not really making this much easier by locking this into a shader graph because I'm probably going to rename all this stuff and maybe even change these arguments, if my hunch is right, and they're the 2 corner points to be origin and I guess radius. But if anyone, I'm not sure off the top of my head what's like the technical term for a rectangle radius or the half dimensions. Maybe it's just half dimensions, I don't know. Okay, so anyway, we've got that all set up. So now I might as well just copy one of these files or one of these shaders. Okay, there we go, fix it. It said there was an error, but okay, well, I guess we're not drawing it by corners, are we? Well, maybe. I don't know. Let's see, draw oriented rectangle. Okay, so this one, it might work. Okay, so I guess we'll get rid of all this, and then I'll get rid of the SDF to put in our other one. Oh, why is the output a vector 4? Should be just a float. Okay, so there we go, and now, well, we're gonna need these, so I'll just leave them, but, well, again, we don't really know what these values mean yet, so I'll just feed them in. Okay, well, something is showing up at least, and now we just need the TH value. Did you end up finishing the grass flower field project? I'm not sure if you missed the stream. No, I've kind of like put that one off because in my day job I've been doing a whole lot with Substance Designer, so I haven't really felt like working on it on stream, but I will return to it for sure, because I know I hate to leave things unfinished. So what does this do? This, oh, okay, so it is a thickness. Oh, I see. That's kind of interesting. So points A and B like define a line for one axis of the rectangle, and then this thickness value is the thickness of the other axis of the rectangle. Okay, that's kind of cool, but I don't really want to specify them that way, I don't think. Thanks, NTT. All right, let's play with this on the quote big screen. I guess let's rename this scene and keep it around. So this will be the axis aligned box. Okay, that's fine. You shamelessly plug your game on a live screen. Well, I mean, if you just happen to talk about it. I think I do have links disabled, but... oh yeah, I want to save this scene as oriented box. Okay, and I'll just duplicate this material so we can leave the old scene in place. Okay. So again, we can... I guess I can just press play and see if my hunch is correct, but I think... Oh, I didn't update the material here. Only if we were making grass would I be able to mention Worldwise on stream. Oh, whoops. Yeah, you did miss your chance yesterday. Oh, actually, no, I was doing the petals. Yeah, I wanted to do grass, but there was an infuriating Unity bug. Or was it really a bug, but... Okay, so this is actually not working how I thought, because I thought you started by defining... Like, I thought that you would draw between 2 points, and then the thickness property did the thickness between them, but it doesn't seem like that's what's happening, unless I've... done it, unless I'm like done something else wrong. Let's see. So we've got, let's close some of these tabs. I mean, okay, there's no way, I don't even do anything with these properties before sending them into the SDF. So what in the world do they mean? Matrix multipliers? Yeah, maybe. Okay, so I wonder... Wrong space, sorry, doing other stuff. Oh, it's alright, mad science. I don't know. Well, technically it should work if all of these are in the same space. And they are all world space, but I think I'm just misunderstanding what they actually mean. Let's see, so I set this one to 1 and then this one to -1. It seems like, oh, you know what? It seems like the Y is reversed. I wonder, yeah, I think that might be it. Because if you see, oh, I'm pointing with my finger, which you guys can't see, but notice that the Y, or wait, it seems like it follows it, but it doesn't like the Y-axis follows it, but then the X-axis. And then this one, yeah, that's kind of funny. It seems like the X-axis of one point follows the cursor while the Y-axis of the other one follows it. This feels like such earnest effort. Oh, good. I mean, yeah, I am trying out. I wanted to try out new stuff on stream, so that's mostly what it will be. A little bit more rough than my tutorials, but I hope it's still enjoyable to watch. Okay. Yeah, so it seems, like I said, it seems like the X and the Y components are like flipped. Because when I'm dragging, one point is stuck to the Y component while the other point's stuck to the X component of the mouse. So I wonder, why is it like that? Because what I'd like to do, what would be the best way to specify this actually. Because I think what I like to be able to just like drag with 2 points. Maybe you can like specify 2 points and then, I don't know, a rotation, but I think that'd be kind of hard to do. One of those about the journey, not the destination situations. I think so too. So let's see, what would happen if I did something like temporary, and then a dot y is b dot y, and then b dot x. Oh wait. Oh yes, I would just want to flip the y values. Let's see how that affects it. Oh, valid subscript. Oh, I forgot the 2. Okay, so now this works more like how I thought. I wonder if that's just like a quirk with CG or something, I don't know. When the world is pretzel rock, seems like a music player. Oh, you don't hear anything? Oh, I think it's just really quiet. I guess I could turn it up a bit. Yeah, it's a music player that just gives you like copyright strike free music for Twitch and YouTube. It has pretty good music, although after a while it does start to repeat because there's not a huge like bank to draw from. But so anyway, flipping the X component or the Y components seem to do the trick. So now you can mess with this thickness value. I could do that with the scroll wheel. Oops. But like I said, what I'd really like to do is be able to specify this with like the corners, and then use I don't know, scroll wheel to rotate around. I probably have to do some trigonometry though, which I'm not super looking forward to. Yeah, the one thing that they do ask you to do is you have that chat bot, which gives links to the music. Since it is free, I can't complain too much, but okay. This doesn't look the best though. So I wonder if I can fix this easier by changing some of these variables instead of having to flip the A and B components. Probably it might have something to do with this being negative. Yeah, so let's I'm just kind of playing around here, but let's try flipping that and see what happens. Okay, so that actually did fix that issue. Okay, so that's good, 'cause that's a lot cleaner. Okay, so now, like I said, I want to try to change this math. So we need to... Okay, so right now this is 2 like points of a line and then a rectangle thickness. And I want to change it to be the 2 corners of a rectangle and then like a rotation. So it can be... Although, is this, maybe this method is easier to input. So if I want them to be the same, maybe I should just have this function work by giving, I mean, I guess that's kind of what the dimensions are. Oh, they just ask you to put different tags on your stream. I guess technically, I mean, the digital art. Well, they didn't have anything for tech art, which is why I put digital art. But they do have. Did I put programming? Yeah, I did. Why is it? Oh, I see. Yeah, I was wondering why it turns white at the beginning, but I think that's just yeah, Twitch is notorious for its categorization or lack. Yeah, I think sometime we were talking how there's no game development. There's no game development category, which is a crime. I think that's one of the biggest problems with Twitch is that it's really hard to be discovered. Like YouTube's not perfect, but it does do a better job of recommending videos, I think. Whereas Twitch, it's really hard to find new streamers, I found anyway. Alright, so I guess I just need to make a decision. Is it easier to specify the box this way, or is it easier to do it by corners? I guess it is kind of easier to do it this way, but for I don't know, for the demonstration I kind of wanted to be able to do it the other way, but okay, so let's just make the scroll wheel increase the thickness of the rectangle, and then maybe I can see about transforming to the other method. I don't know. I just think it's gonna involve trigonometry, which is a little intimidating, but let's see. Anyway, what was I gonna do? Oh yeah, the scroll wheel thing. I guess I'll do it in a different script. Rectangle thickness by scroll wheel. Oh, also, I should probably rename these variables now that we kind of know what they mean. Although, okay, this is kind of interesting. Now I know this is like the dimensions of the rectangle. So, yeah, like the half radius of the rectangle is right here. So I could do that pretty easily. So what does this Q mean? Is the Q... I think it transforms the point into like... It like rotates it so it's in the same rotation frame of reference as the rectangle. And then this is the radius. So it might not be as difficult as I thought to do it the other way, but... Could I ask one more meta topic question? Oh, it's alright, mad science. It doesn't bother me. So thickness. Okay. And rename this to thickness, and then I need to set the reference so that script can read it. Oh yeah, let's clean this up a little bit. Oh, sorry, I got an urgent alert on my phone, but it's just somebody misusing the system. No big deal. Okay. Oh yeah, so I want the property name, and then private float. I guess increment. I think it's a serialized field, right? Okay, and I guess I'll need like an at value. Seems like I've done this before, but can't think of what script it was in, so we'll just rewrite it. It's not going to be very difficult. Yeah, didn't I thought I did I remember doing this on stream because I remember saying I should make a video about the scroll wheel. This is set float, property name. What should I initialize it to? And then we'll say at thickness equals the initial value. And then on update, I need to get the scroll wheel from Unity, which I think, if I remember right, is get axis. It's like mouse scroll wheel, something like that. I guess I should look it up. Yeah, mouse scroll wheel is the default setting. Alright, so if I think you can do like if it's not 0, because how it does it is every time like your scroll wheel clicks, it sends a negative or positive depending on the direction. So it's not like continuous. So I can just say if I don't know. I'll use the lowercase m math. So if it's the absolute value is less than a small number, then we'll just say it's 0. Back to a new server. I heard when I got to stream fun that you had a Pokemon. I inquire about them for when. Talk about evening later. Oh, yeah, I'm a big fan of Pokemon. I've been playing it since I was, well, basically since it first came out, actually. So, yeah, I have 2 Pokemon plushies back there. I have a Spheal and then a Turtwig. I have some other ones. Maybe I'll switch them out every once in a while. Yeah, plushies are kind of my, I guess, guilty pleasure. I don't know. I've always liked plushies. That'd be a fun Easter egg. Yeah, I think so too. All right. Yeah, so if it's less than a small number, then that means it's basically 0. I actually think wheel, when you get it raw, is never less than 1. Well, the absolute value is never less than 1, but... Okay, so now we can say at thickness, add the increment times the wheel value. I was wondering if I need to have a bound property. I mean, there's no reason for it to ever go negative, so thickness equals math. I guess we can just let it be unbound in the positive direction. So this means it will never be less than 0. And oh yeah, now we need to set it in the material. All right. Okay, so I'll add this to the control. Thickness, increment by, I don't know, 0.1. That might be small, but no problem, Mad Science. If you have any other questions about them, I don't mind that answer. Okay, so nothing is happening. Is it, yeah, when I'm pressing the scroll wheel and it's not changing, but I did set the thickness. Okay, so it's stuck at 1. Let's see, so something is going on. Okay, I was wondering why it had that 1 parentheses there. I guess I just... Oh, okay. I have a... Yeah, I have the outline thickness. I guess this should be the rectangle thickness. Okay. Not that it's just a name, but... So... Update... Seems to be running every frame because it's setting it to 0, but it doesn't... Oh. Yeah, I did this wrong. This should be greater than that number. We did it opposite, of course. Excuse me. All right. So, okay, there we go. But the increment is too small. So let's increase that. All right. Yeah, and so, okay, that's kind of interesting. When you set the thickness to 0, it looks just like my the line segment SDF we did in the previous video. So there is like a certain elegance to defining the rectangle like this. I just don't really like the oriented box and the axis line box being defined different ways. Although, I mean, they're not, are they really? Because the axis line box can't like move around, so I don't know. I probably shouldn't worry about it too much. You love the stuffiness. Tell her I love it too. Yeah, maybe I can show you a bit closer up. I don't know. It's pretty big, as you can see. Oh, now it's actually off camera, but that's all right for now. But yeah, it's made of, it's almost like a pillow, or I don't know, memory foam. It's a little bit thicker, or like, I don't know how to describe it, like firmer than a pillow. Anyway, maybe I need to make a plush on stream. That would actually be kind of interesting and fun to do. That kind of like fuzzy fabric is probably kind of difficult to do as a shader. Hey Austin, thanks, I'm glad you like my videos. Thanks for coming by. Plushy vid would go viral. Yeah, that might be a kind of good idea, actually. I haven't seen... Well, it'd be really... I mean, there's a reason why fur and stuff is difficult to make and fabric in games, but yeah, it would be fun to do. For sure. Anyway, okay, so I think I've talked myself into just going with the math here, because I think this is the easiest way to specify a rectangle like this. I mean, we could do it like the size and rotation. I mean, maybe we can do that. I don't know. I don't think that'd actually be that difficult. Let's try it real quick. If it doesn't work, like, it's hard for me to do math on stream because normally I would just write it in real life with a pencil. To try to draw diagrams and stuff. So if my hunch here doesn't work, then I don't know, maybe we'll just move on to something else. But so okay. Make it from grass. Actually, grass and fur has a lot in common. But all right, Mad Science, well, thanks for coming by, and I'm glad you enjoyed the plushies. Have a good night. Okay, so let's see. And this way would be through dimensions. So again, we'll have a dimensions and offset, and then angle. Which, so here is just the dimensions, because you get the length between A and B, and then the thickness. Also, I need to, oh no, that's fine. So I know that is how that works. So this Q, see, I think this multiplication is rotating Q. I think it's just a 2D multiplication. And all it is getting, so it's getting the line. So this is normalizing the vector that points from B to A, which is the direction of the line. So yeah, that's basically just a little trigonometry, isn't it? I just have to do sine with the angle. Okay, and then the offset, again, we would just subtract from P at the very beginning. Like, that's kind of what it does right here, I think. Okay, so D would now be, again, I don't know, having to do trig in my head, which is probably a recipe for bugs. So, right angle, I guess I could just open up paint or something, I don't know. I mean, no, we can do it in Inkscape. Take Takes a bit to load. Okay, so we have so right now it's defined like, oh, of course it's not going to show up. There we go. So we've defined the rectangle. Oh. Of course, making it difficult. I want it to just be a straight line Inkscape. That's fine. Okay. So we're defining the rectangle based on 2 points A and B, and they obviously form a right triangle. But instead we want to specify an angle. So if we say the angle's here, all right, so okay, let's see here. In the original one, we set B and A there. And then this direction is bx minus ax. And then this length is by. Oh, I did that backwards, didn't I? Yeah, this should be y. Okay. And yeah, obviously this is oops. Wait, I do want it to be a stroke actually. It's just too big. Okay, so yeah, that's supposed to show this is a right angle. Okay, so if our angle is right here, then so this cosine is, oh wait, no, the sine is opposite. Okay, so we actually need the tangent, right? Because the tangent is opposite over adjacent. Might have that backwards. I never was very good at memorizing all these trigonometry identities. Okay, so opposite over adjacent. Okay, so we have tangent of theta, or of the angle. I guess I'll just call it G. It's fine. So G is the angle. Is the opposite over adjacent. Although, okay, so we're given the dimensions of the, but okay, so the dimensions are already rotated though. So how are A and B? Basically, I need to compute both the dx and dy, and then I can construct this or this matrix from it. So the tangent will give us the ratio of them, but then that doesn't help us find. Well, I guess. Well, no, it doesn't help us find these individual components. So let me think. Well, okay, we do know the dimensions, which means we know the length of the hypotenuse. Yeah, so we don't need to do tangent. We just need to do cosine and sine, because we know this direction. So that means, let's name these. I guess I'll just call it, don't really want to call it X and Y, and then A and B are already taken. Let's call that one K and this one L. Doesn't really matter. Okay, and then we know this is the dimensions.x. So what I can then do, okay, so sine is opposite over the hypotenuse, and then cosine is the other one. Okay, so I can just take the cosine of the angle multiplied by, oh, except these are all normalized, so I don't even need to multiply it by anything. I can just take the sine and cosine, I think. Okay, so I made that a lot harder than it needed to be, but it's alright. Sine angle equals cosine angle. So I don't need this length anymore. D. I don't need that anymore. I can just, so I can replace these x with the cosine, and then the y's with the sine. And then this, instead of doing that, I just need to subtract the offset. Okay, so I think this should work. Okay. Oh yeah, it's gonna say, oh yeah, I changed that variable name, so there we go. Okay, so now let's make another shader graph, I guess. Okay, so the original one will be by thickness, and then this other one will be by a rotation. Okay, so dimensions, offset, angle. All right, I need to change this. Thickness. Yeah, and I'll just change this to be angle. Oh, I need to copy this one actually. Yeah, you could probably combine these together now that I look at it, because, well, I don't know. Actually, yeah, I think they have enough different that it'd be kind of difficult. I guess when you get to this part, you could pass in the matrix and the dimensions, but anyway, this is dimensions, offset, angle. Okay. Undeclared. Oh, right. I need to change this. And probably the other one is going to complain as well. So let's go fix that. Okay, there's still something wrong. Undeclared oriented box thickness. Oh, I put it in the wrong spot. It should be SDF thickness. Okay, there we go. And then the other one. Okay, and so now I just need to change these to dimensions. Offset and angle. Okay. And now I need to do the same thing. Make a duplicate of this. shader graph, but first I'll save the current version. Right, and then we can use the other. Oh, that must be a problem because it's not seeing our subgraph. Oh, it's because I call this rotation, not angle. Still not showing up. Oh. I feel like something's wrong because I don't know why. It didn't show up in that search, but everything looks okay. Anyway. Okay. Yeah, these references don't match anymore, but I don't know. I don't think I'll specify our control this using that same script. Yeah, the other way definitely works better for the script, but I kind of want to see if this works. Well, that's not a good sign. Oh, actually, that's okay, I think. Because it did offset it. So the offset seems to work. Does the dimension? Okay, well that was negative for one. Oh, it does seem to work. Okay, so let's see if angle. Oh, cool. It did. Can't believe it worked on my first try. All right. Well, great. Okay, let's just try it on the big screen. Let's just make another material for it. This will be, yeah, like I said, the thickness version definitely shows better or is easier to control, but I just kind of wanted to see if I could make this version. It might be, like, I don't know if it's actually easier to work with, but it turned out to be a interesting math problem. Okay, so I'm not going to actually control it, but I just want to make sure that it works okay. Okay, and then, yeah, you can offset. And then you can angle. All right. I guess we should make sure this angle seems to work. Okay, so 3.14, which is 2 pi, or 1 pi should turn it around once, and it seemed like that did. So, okay, so that's a good sign. I guess it could be, okay, so when it's positive, or as you move in the positive direction, it rotates counterclockwise, which I think is fine because it's like counting the angle starting from horizontal and then moving up, which I guess is the one that makes the most sense. Okay, well, cool. That's fun to play around with. All right, so actually ended up. So I wasn't. This actually was pretty easy to derive this function, or easier than I thought. Well, I guess I still haven't like derived it, but I don't really know how to do that on stream. So the only thing I don't really understand is this part here. So it makes sure that this point, it's probably similar to, actually wait, it is similar to this because it makes sure that the distance is greater than 0. And then you add the maximum component here. So it does the same thing here, except, yeah, so this whole part is just like rotating the input point to be in the same reference frame as the rectangle, so then you can apply the normal box SDF to it. Actually, yeah, I think this derivation is a little bit easier to understand. So yeah, we take the sine and cosine of the angle for the rotation, and then you just this is just a normal rotation matrix that rotates this point Q to be in the same reference frame as the rectangle, as I said. And then you offset, yeah, you also offset it by our offset, so that way, just so that 0, 0 is at the center of the rectangle. And then this part, okay, so you take the absolute value. I guess that's just so it's symmetric around 0. And then you subtract the dimensions. Okay, so yeah, so that's Q. So you're kind of finding, at first you're finding the point or the distance of the input point from like a point at the center of the rectangle. So it's when you add you subtract the dimensions from it that you start to actually get a distance field. But I think right now when you subtract the dimensions, it's going to be circular. I'm kind of... What happens if I just returned the length of the Q? Let's see what that looks like. Okay, so that's kind of interesting. It just gives us... Okay, well... Oh, I see. So it gives 2 points. So it just gives you the corners of the rectangle. That's kind of cool, actually. So yeah, but this... Okay, so right now... So what about if I took away this line? I think it would just give us... Okay, so that's interesting. It just gives you the... Okay, well, I guess it's like I said, it's giving you the distance from a point in the middle of the rectangle. And so angle doesn't really do anything. So it's this part that transforms it to be... to deal with the dimensions of the rectangle. But yeah, it gives us points. Maybe this would be easier to visualize. Well, I guess I can just increase this thickness, but I was gonna say if I had like a wavefront like Inigo has here, but anyway, okay, so right now we have I guess SDF to the corners of a rectangle, which isn't super interesting. And then so if we take this part away, what happens? Okay, so that kind of makes sense. So now when you have the maximum, you take out the parts in the middle of the rectangle, which were subtracted out when you subtracted the dimensions. And so you're left with this SDF. Or so you're left with the rectangle. So there's other things I guess they just add the points around it? Or is that part of the... No, because if we set the smoothness to 0, that gives us like the point at which the SDF equals 0. And so it's definitely rounded. Oh wait, maybe not. No, yeah, we have to set both to 0. So at this point, the SDF is equal to 0. Oh, I see. So the thing now is you technically don't have an SDF. Well, I guess you do. You have the SDF to a solid rectangle, but SDFs should be give you negative values when they're inside of a rectangle. So maybe that's what this next part adds back in. So it gives you the minimum between the X and the Y of the Q. Okay, I turned to 0 because the thickness was 0. So yeah, that is what I think that's what this last part, that last term does, is it adds back in the negative part of the SDF. So again, if we take this out, yeah, so it's just solid. Which, I mean, if you don't care about the negative part of the SDF, then I guess you could take that for a very small optimization. Okay, so that's kind of cool. So what exactly is this doing? So yeah, this part, again, is just the distance from Q. What would happen, yeah, if we, like, how come it doesn't just use, like, the length of... Oh, we already did that. That gave us the 4 corners. Yeah, I was going to say, how come we need to have this max part here? We can't just have the length of Q. Maybe it would be... Yeah, let's make something real quick. Maybe that will visualize like the gradient a little better. I guess I could just do a sine wave. I was gonna go get my the rainbow I had in the other video, which I probably will get eventually, but let's see. And then, oh, actually, it's better if you use cosine, because that way cosine will be 1 at the edge of the SDF, which tends to give you more realistic or easier to visualize points, I think. And then we'll remap it so that it ranges from 0 to 1. Alright, so let's look and see. It's kind of hard to tell. So let's add a period. I don't really... doesn't have to be super clean right now. Technically this is going to be a frequency, but... Okay, so yeah, so now we can see... I'd like to visualize the negative part a little easier. We can color it differently. Well, I guess we basically just use it as a mask. Okay, so saturate. So I want it to be where it's negative. I want it to be red or colored red when it's negative. So I guess we'll negate it and then saturate. So this should be. Oh no, we don't. We can just use a sine function. Yeah, so that'll give us a mask, and then we can just add a tint here. So multiply, I don't know, with red color. I'm not gonna. Oh, that's not what I wanted. I'm gonna add a property for this because we'll make something that looks a lot better soon. I just want something quick to visualize how this will go. Okay, and then we multiply again. Okay, but now everything else is black. Oh, what am I trying to do? Guess we can use a blend. Yeah, that was probably simpler in the first place. And this could be the mask. And then we can just use overwrite, which is kind of like alpha blending. Okay, there we go. Although, oh, okay. So the reason this is tinted blue, I think it's because it's giving us -1 in the other positions. I just want this to be something simple. So saturate. And then we do need to multiply the sine wave with red for this other part. And I do apologize for this being messy. Okay, there we go, finally. Okay, so the reason I did that is because I wanted to visualize for sure how all this looked when you change some of these values. So again, when we just have the length Q. Okay, so yeah, it just gives you the distance from the corner points and there's no negative values. So by taking the maximum. Oh, okay, yeah, because this is the length. I was going to say this doesn't give us any negative values, so why would taking the maximum? So there must be negative. Yeah, so this maximum is removing negative components from Q. I'm just curious, what would happen if you just did the negative components? Okay, then you get like a cross. Okay, so I think I kind of understand. So we're just using this to take out the negative components, which are all like in the middle of the rectangle. And then this last term returns or gives us back the inside or the values inside of the rectangle. And I guess it's pretty much the same thing that happens in the axis aligned box. Because yeah, the math is the same, except here we've just rotated Q to, again, be on the same angle as the rectangle. Okay. I think not too bad. I should be able to describe that in the video. Okay, so let's clean this graph up. All right, and yeah, let's give these better value references because they don't match anymore. I don't think I'll make a C# script to control this because I don't think there'd be any good way to do it, and the other way Just makes more sense to control with the mouse. So yeah, let's put this back onto the plane just to make sure I didn't mess anything up. Okay, so that was fun. Still have an hour, so what else could I do? I mean, we still need to make the a rainbow visualizer of this SDF. Let's see. I mean, we could do a rhombus, but basically we can derive that from these equations because you just set the dimensions to be the same. Although wait, no, that's not true because the in here that's not all right angles, so that's probably a different video. Maybe do rounded corners. Let's see how that works. Yeah, the rhombus does look cool, I think. What's n dot? Maybe negative dot. I don't know. I haven't. That's again, this is in CG, so. All right. So for rounded box, how does this work? So the XY. Okay. So again, not very descriptive, but I think this B is the dimensions, and then R is like a rounding factor for each point. Because you can obviously change them separately each point because they're different values or yeah, different rounding. And then, so anyway, so if the X and Y, so if X is greater than 0, then, oh, I see. So it's choosing different rounding values depending on if X is like above or below the origin. Probably. Yeah, so this is, I think, just choosing the rounding value to use. So this picks between the what, or the horizontal ones, either left or right. And then here, this is picking between what we just chose for the top or bottom. So it just picks the correct rounding value. So we could get rid of all that if we just wanted to have a single rounding value. And then this takes the absolute value of Q or of P, which is similar to this. And then it subtracts the dimensions, which, oh right, this is actually the half dimensions, but, and then it adds in the rounding value. And then it's the same. Okay, so okay, this is the same as the box, except he's flipped them, but it's the same math here, and then you subtract the rounding value out. Okay, so that's kind of interesting. So you add it to the point, and then once you've done this, you subtract. Okay, I think I understand how that works. If you look at the field here, you see that the values naturally round as you proceed outward. So I think what's happening is it's like pretending that the SDF is out farther than it is, and then testing that, and then it brings it back in towards the rectangle to make these rounded corners, if that makes sense. Yeah, because this is a scalar, so you're adding it both to the X and Y, which in effect moves it. We'll just move it this way, wouldn't it? I guess that must work well enough. I was gonna say it moves it outward in the direction that you're moving, but I don't think that's actually true. Unless I'm misunderstanding what R means. I guess we just need to test it. Okay, so let's make one more. Okay, now do I want to... I was going to say, do I want to add this onto the oriented box? And make like a mega function where we have the oriented box rounded. Okay, well, I mean, maybe we can try that. I don't think it'd be that difficult to do. Let me think. So the only difference really is this. The only difference between a normal box and the rounded box is you add the rounded at this computation and then subtract it at the end. So for this, we would just add the rounded value here and then subtract it here. So I think it's actually going to be really easy to add rounded value. Or we could technically just add a rounding we could just add a rounding factor to these functions, which I think I might do. And then we'll just have an outside function that will let you choose for each corner, because, I mean, it doesn't really have to be part of this. So float rounding. So we add it here and subtract it here. And I can add it, do that to each part. I almost didn't subtract it. And then add a rounding variable. Okay, so now it's going to complain that these functions don't have it. So let's add some arguments here. And I think that if you don't want rounding, you should be able to just set it to 0 and it will be the same as before. Now, I wonder if you set this to negative, will it make the SDF more pointy? Because that's something I was also kind of curious to look into. Okay, so yeah, now it's just saying that the these graphs need to be updated to have the new value. No matching. Did I not? Oh, I didn't add the argument there. No, I'm kind of expecting this to work pretty easily, but I guess with my luck it might not. Oh, I should clean up. I guess it doesn't matter because I don't know if I'm going to keep these. Oh yeah, that's something else I should do. I should try to convert this to a shader graph, but that's not that difficult. I mean, I guess it is a little... going to be a bit complicated, but... Okay, let's add a rounding value to here. And then I update all these so the shader graph should be fine. And then this is thickness, so now we'll add a rounding value and just feed that in. That'd be kind of cool to also be able to control this with the C# script. Maybe I can do it if you like hold shift and then press or do the mouse wheel. Okay, so let's see. Yeah, so with a rounding of 0, nothing happens. And let's hope. Okay, cool. So yeah, when you increase the rounding, it rounds out the edges. Kind of interesting when you... Oh. Yeah, so I think, like I said, I think all it's doing is like moving... It's like moving outward on the SDF and then contracting back in. Because like like I said, the SDF naturally rounds as you move outward, so I think that's basically what this math is doing. Now if I set it to negative, okay, it does, that's kind of cool. It does like, I don't know, make the SDF more pointy. I don't know the right term for it, but it seems like if you keep going negative, it doesn't actually affect it anymore. Okay, so I guess I should make sure it works with the other types. Okay, so that's not the best sign. Oh, but I didn't add a thickness property to the shader graphs, I don't think. Or roundness property. Okay. Huh. What did I do here? So something's not working, obviously. Is it... Let's just set this. Back to default values. So it is responding there, so for some reason the entire SDF has blown out. This is using the draw rectangle. Just make sure I didn't do something weird. It's kind of, it seems like it's working in the shader graph. Oh, yeah, when I deleted all that visualization code, I didn't hook up everything. Okay, there we go. Okay, thankfully it seems to work fine. Now let's just do the axis aligned box real quick. Oh, yeah, be consistent, so I'll call this rounding. And here, add a rounding value. And then I guess this other one that's just centered. Okay. So if I will, well, I guess let's test this. All right, and then move to the axis aligned scene. Okay, so that is working. Oh, did I not? I thought I added it. I have too many shader graphs open. It looks like I didn't save it. Okay, yeah, so this works fine too. So now, I guess we can just try to add a rounding per corner. It's basically just going to be, all we have to do is we can feed in a different rounding value to each of these subgraphs so I don't have to make like a separate subgraph for it. So this will be, or a separate subgraph for like individual rounding. So round. Although, okay, now that I think about it, in order to do that for these rotated boxes, we have to basically do that rounding code after it's like been transformed. So we'd have to choose the right rounding value right here. Okay, so that kind of messes up my plan, but I guess let's just put float 4 rounding into each of these. It's not a huge deal. I'll just have to go and update those functions I already wrote, but that's okay. And yeah, I kind of want to create like the most fully featured version of each of these SDFs, and then like if you're using them for an actual game, you can take out what you don't need. Get rid of this comment. Okay, so it was like this code is a little hard to understand, I think. I mean, basically he's like choosing a correct rounding. But I think if I just stored these in different variables, it would make more sense. Even if it's not quite so pretty. Oops. Okay, so float 2, rounding horizontal. And then float rounding final is okay. So let's make sure this works before I copy and paste it to the rest of them. Oh, I wish I thought of this before I went and made all these. Because now I'm gonna have to go and update each one again, but that's okay. Yeah, you can't. I kind of wish you could change the type of property after you've created it, but I don't think that's possible, unfortunately. All right, so no errors. That's a good sign. It's also the fact that the ordering of the corners might not make the most sense, but I guess let's wait. Oh. Yeah, I made a float again. Okay. Okay, so this is the top right, bottom right, top left, bottom left. Is this? Oh, you know what? Yeah, see if I offset here, you can see, yeah, they're breaking apart because I need to do this after the point has been offset by the rectangle offset. So I just do P minus equals offset. Okay, so that should fix that problem. So now, yeah, when you change this, it doesn't affect the rounding. Although, yeah, there's still these breaks, and that's just because, you know, the rounding corners don't match naturally, so you've got to be a little bit careful with what you do. It kind of, yeah, the order here really doesn't make sense to me, so I kind of would rather it start in the top left and then go around like that, or start here and then go clockwise. I don't know. I mean, either way is kind of arbitrary, but I guess it'd be better starting at the top right and going counterclockwise because that's the same way that our rotation angle goes when we move to the rotating rectangles. So that is already right, and then this one. So I've got to change. So the horizontal, technically, is that? So the first and second should be top and bottom right. Is that correct? Yeah, so if I want this one to be number 4, then I should do XW. And then next one would be, okay, so that's should be Z. Wait, this is W. Okay, so I want, oh, okay, that's confusing myself. So I want to find these 2 points because I'm trying to choose between the right and the left. So right now, this one is, wait, so it is XY. Oh, but I want Y to be here. I had it like clearly in my mind, but now I've confused myself. So let's see. Okay, yeah, so I want this to be the last in the array, so this should be W, and then this one should be Y, so I need to switch that out. Or I think it should be YZ, actually. I don't know, let's just see how this looks. Okay, so X, Y, oh, okay, good so far. Okay, I did it. Yay. Okay, so now, excuse me, so now let's apply this to these. So I think I can insert it here. And then this. And then for this one, I can also insert it right, excuse me, right there. Okay. Now, yeah, for the rotating ones, the corners are gonna be kind of confusing, but it would be like if it was oriented a specific way. Don't think I updated the shaders yet. Yeah, they're just floats. So I need to change this to a vector 4. Delete that. Delete that. Same thing over here. And now the draw graphs, of course. Oops. Okay, so far so good. Hopefully this is the last time I have to change these. All right. And okay, so right now the ordering is good, but obviously if I... Oh, that's weird. Okay, so that's not correct. Seems like... That's kind of interesting. Oh, I think I know what the problem is. Yeah, it's choosing the rounding based on... Not based on the orientation of the rectangle, but like in world space. And that's because here I still use P when I should change it to Q, because Q has been transformed in the same orientation as the box. So I think this should work. Not quite. Or maybe it's just because the thickness is so slow. Yeah, I think it was fine. It's just the thickness was so small that the rounding was not looking the best. Yeah, and I don't think that the bug is really easily fixed. If we set like the rounding to 1 for each of them, does it look good? Not really. Yeah, so you don't really want to have any rounding if you're gonna have a really thick, a really small thickness. But I guess at that point you have like a line segment anyway, so why would you want any rounding? And then yeah, it does flip around depending on what the angle is. Okay, so let's try our last material, the angle. Okay. Oh, I am still on the thickness one. It seems to work. I wonder if there's a mathematical threshold that you can calculate to clamp the value so it doesn't break. There probably is. I think, yeah, more of an afterthought. I think, it'd be kind of complicated actually, because you'd have to kind of like do it for each corner approaching the center on each direction. But yeah, I think that would be interesting to maybe follow up on. I probably won't get to it tonight, but yeah, I'm sure there's some way to do it, because things like Bezier curves and such do have that kind of smoothing, so it might not be too different. Anyway, I'm pretty happy with that. It looks pretty good. Alright, so what else? Okay, I guess I need to make the shader graph versions of all these SDFs. And then, make some kind of pretty visualizers. We have 45 minutes, might be able to make good headway on that. Okay, so I'll start with the axis aligned box. Okay, I guess I can delete this because we're not using it. And I think I'll leave this custom function, but I'm going to recreate the code using shader graph nodes. Just because I think a lot of people are more comfortable with the shader graph and would rather just be able to build it without having to open any code. Now can I, disconnect. But I'll just leave this around in case I need it later. In the actual video, I probably won't even show it, but... Okay, so for the box... Oh, this rounding part's going to be kind of annoying to do. Oh, well. Let's see, how can I... There we go. Okay, so first thing I need to do is subtract the offset from the input point. And now I need to use that to choose this rounding. So maybe I will need a subgraph after all, but let's just go ahead and create it in here and then I can spin it off. Okay. Branch. Yeah, you have to do this as a branch. Okay. Which I actually have barely used in shader graph. What's it called? Test? Is it conditional? No. Predicate? No. Compare. Yeah, comparison. So I want if x is greater than 0. Again, I need to split this. So if x is greater than 0, use that as the predicate, and if it's true, then we use the rounding xw. So I need to split the rounding vector and then form it back into vector 2's. So if it's greater, we use xw. If it's less than, we use the other two. Okay, so I think that's right. And then I got that branch. And now we have to do the same thing if y is greater than 0. Don't know the best way to... route these values, something like that maybe. And then I have to split this branch. And if it's true, we use x, and if it's false, we use y. Okay, maybe I could just do that. I don't know what's easier to read. Okay. This could just be a float. Actually, I probably forgot to change that earlier. Okay, so now we have the rounding value. So now we need to take the absolute value of the point. And then subtract the dimensions from it. Or half the dimensions, actually. And add the rounding value. Probably move this up because they're kind of parallel. Okay, so that's this line. And now we take the length of the maximum of that and 0. Adding, so we need to take the maximum of the x and the y and then make sure that is less than 0. So to do that I have to split. And minimum, oops. And 0. Okay, and then, okay, so we add these two things together and then we subtract the rounding. Okay, and that's it. You just return that. Okay, that wasn't too bad. It'd be a lot simpler actually without this rounding bit, which I will separate off into its own subgraph, I think, once we've got this working. Now this other one, they'll be a little bit more complicated, but... Okay, so let's make sure this works. In game, switch to the axis aligned box. Okay, something is wrong because I'm supposed to be able to... Seems like the dimensions are too big. Did I, see here. Forget to or multiply by 1/2. Yeah, multiply by 1/2. Oh, okay. This is kind of an annoying thing. I want this to just be 1/2. Yeah, when you do that with vector 2s, it kind of promotes it. So I think it's just better if you do something like that for all of them. Here it's not quite so bad because it's just a float, but... Okay, so I think that should fix it. Looks like it does. Let me make sure that I didn't break any of the rounding stuff. Cool. Okay, so now let's try to recreate this. It's a little bit more complicated, but some of it we can reuse. Because basically, so I think this part is exactly the same as this part. Basically, because all we do is we transform the P to be in the same space as the rectangle in all of them, and then we find the rounding value and then apply the same math to it. Here the dimensions are a little different, but it's the same type of thing. So we can actually... You know what? Actually, besides the offset part, we could just use the box SDF as like the base for all the other ones, which is kind of cool. So all I'd have to do is send 0, 0 as the offset, and then we'd be set. Okay, so let's do that. So first I'll do... Oops. We got thickness. Too much open. Okay, so again, I'll keep this around. Disconnect. And then I can use the other box. Oh, not that one. The axis aligned box. Okay, so that one can just be the output. So I just need to figure out these things. So basically we just have to recreate this first part. So first we gotta get the difference of B to A. And then, so this is basically finding the length. So what else is? Okay, yeah. So the length is also again one of the dimensions. Okay, we also have to add them together. Move this out of the way for now. Okay, I was getting kind of ahead of myself. So we've got the length here, and that gives us L. And then for D, we have, again, the difference, and it's just dividing by L. If I want to, I could just use a normalized node here instead of dividing by L. But I guess we can save a little bit of work there. Okay, so now Q is a transformed point. So yeah, this A plus B times 1/2 is just the offset from before. So that, and then multiply by 1/2. Okay, and so we subtract Yeah, so we subtract input from that. Let's do it. This. Okay, so now we've calculated this part. So now I need to construct this matrix and then multiply it. So I need to split this. And I think I can make a matrix here. Yeah. Oh no, can you not? You've got to be able to specify a matrix. Matrix construction, okay. I think it's row matrix, but that scared me for a second. I was like, got to be able to make a matrix in the shader graph, but then again, there are a lot of things that just don't work for whatever reason. Okay, so the first two go in there. Okay, now we need to negate the Y. And compose another vector. Okay, and then this goes in there. And then we only have a 2 by 2 matrix, so we'll take that out. With Q, which is this part. I think it's complaining. Maybe because these values aren't set. Let's just set them to some values so that we won't get divided by zeros. Okay, so now we have that, and I think all we have to do now is feed everything into the normal rectangle SDF. Okay, so the dimensions are the length that we calculated here plus the thickness value. And the offset 0, and then the rounding we can just pass directly through. Okay, so I'm a little worried that this won't work right away. Mostly because I don't know if this matrix construction is going to form the same way that it does in HLSL, but I guess we'll find out. This looks a little messy, but I don't think there's any better way to do it. Let's go oriented box. Okay, actually, maybe I was worried for no reason. Yeah, it seems to work perfectly. Okay, good. And then let's just test the rounding. Oh, it's the wrong material. All right, great. Okay, so we've got one more to do. This SDF angle, which is a little bit simpler than this one. All we do is we basically construct the matrix from the sine and cosine and just subtract the offset. Okay, so close that and then, oops. Need the shader. Okay, so again, let's disconnect this, but then leave it around. And I think so I don't have to rewrite all this. Maybe I can just copy this code. Or at least the part. Well, I don't know. I think I might just leave myself open for bugs. It's not that complicated, so. Alright. Okay, so first I need to get to the sine and the cosine of the angle. Okay, and now we subtract the offset from P to get Q. Okay, and then we form a matrix. So I guess first I need to make the two vectors. So the first one is cosine and sine, and then I need to negate the sine. Okay, something like that. I don't know what looks better, but... Okay, and now we need to compose a matrix of this. Which thankfully is not very difficult. And multiply it with our point. Which I guess I can bring down here. Okay, and now I just feed that into the axis aligned SDF. Okay, and so the dimensions, this one's a little simpler than the other one because the dimensions are just what we pass in. And same for the rounding value. Alright, so let's see how this looks. Okay, good. It seems like I transcribed it correctly. Just testing everything out. Okay, well that wasn't quite so bad. It's really cool that you can just reuse the normal box SDF and these rotated ones. Okay, so we have about 20 minutes. Let's go ahead and apply that rainbow effect. I think the easiest way to do that is just export it from my previous project. Oh, I don't have to do that. I can just import. I already have the asset ready, I think. Okay, so I just want that. And okay. I think this is fine. It's probably going to complain it's missing a subgraph. But that's okay. Oh, unless I cannot find subgraph asset with GYD. Okay, well, it's not even going to let me import it unless I get... Oh, wait. Yeah, it's right here. Okay, yeah, it's just complaining that it doesn't have the line segment SDF. And all I have to do is just put in the rectangle SDF I want, which I guess, let's just go with the the thickness version because that's easy to control with the mouse. Now we've got world position and points A and B. And so I need a rectangle thickness and a rectangle smoothing. I call it rounding, actually. Okay, what else? I need to change this to have the thickness reference so that the script can use it. But I think that's good. And then I guess I'll move this out into the rest of the game files. Okay. I should rename the shader as well. Okay, so let's make a copy of this effect of this scene. And then I can place it onto the plane and also in the control. Okay, cool. Seems to work just fine. Now, let's see if I change the rounding. Okay, I was kind of curious what would happen. Yeah, that's interesting. So if you increase the rounding, you can see it makes them it makes the corners pointy farther out, or I should say decrease the rounding, which I guess makes sense from how we knew it worked. Thanks, NTT. Yeah, I really like this effect, and it got it seems like everybody that watched the videos liked it too. So okay, well, cool. Let's see. I'm trying to think. I would like to use this effect in something besides just showing off the waveform, but I'm not sure. I'm trying to think of. I guess I mean we could use it to do like a checkerboard, but that's kind of boring. I can't. I think seclusion tower. Off the top of my head, I can't think of procedural material that I could just throw together real quick that uses the rectangles, but maybe it'll come to me. But anyway, I think that I'm pretty much done with the SDFs. Like I said, yeah, for the video, I'd like to have like a example to use it in some other way besides just like these theoretical graphs, which are cool in and of themselves, but I don't know how to think about it. Let's see. Procedural material rectangle. I guess you could do bricks. see myself using something like that with rhombus style to make a teleporter texture. Oh yeah, that would be cool actually. Do something like that. Yeah, bricks actually, I think is a good one. You could throw, yeah, I don't think that would be too difficult to do. Let's see. I don't really have a ton of time, but maybe we can get something done. It's probably a better way to do it, but what am I looking for? Okay, so we can just use the axis aligned box for this, just for simplicity. Alright, so basically there'll be like a brick thickness, and then so we need to offset every other row. So we need like a sawtooth. A good way to do that is with a sine. Okay, let's do some properties. Okay, brick dimensions, and I guess mortar thickness. I don't know the best way. So like the actual dimensions would be brick dimensions, or yeah, plus the mortar thickness. Do something like that. And mortar thickness is 0.1. Okay, so now we need to like get the world position and like divide it by this value and then take the fraction. Position. Okay, and so this should give us like the it'll divide this up into tiles. And then if we want 0, 0 to be in the center, which I think we do, we would just offset yeah, we would just subtract 1/2. Okay. Now if I put this in here, okay, you can already see something going on, but okay, so the dimensions actually, okay, I think I'll, oh, so the dimensions, no, I guess it is the brick dimensions, but I need to also divide this because they have to be, oh, I guess I could multiply this back into dimension space. I don't know what would be the easiest way to do this. like that, and then okay, let's just see how this looks. I don't know, actually we might not see anything. So I do want to take the maximum of this because we'll get rid of the negative values which are inside the brick. And then I guess we do want a smooth step because the thickness should be the mortar thickness. Divided by 2, so it should be 1 at that point. Probably getting some of this math wrong, but that's okay. Figure it out. Okay, so I take that in there and so it's 0 at the edge of the brick. So the maximum should be this mortar thickness. Okay, let's try it out real quick. Make sure I save it first. Don't need that anymore. Okay, nothing so far. Oh, because I haven't changed the shader graph. Okay, so nothing at all. So this is working okay, and oh, I think I know what's going on. Yeah, I should actually multiply this like that. Yeah. Because what was happening is I was multiplying the bounding box by the brick dimension, so the distance never got greater or never went above 1. Okay, so there we go. So now I just need to offset each row. And then we can add some noise or something to make it look more like actual bricks. I'd like to at least do the offset before I leave tonight. I have 3 minutes, so let's see. Okay, so basically I just need to take the Y value out of this part. And then multiply it by 2 pi so that it has a not contrast, so that it has a so that the period of this is the same as the height of 1 brick. Okay. Is that correct? Oh yeah, this. I think I actually need to do it this part. I can see by the waves that it's actually oscillating like in the middle of a brick. So if I just change it to 1 pi, the period is 2 bricks, which is actually more what we want. And then we can turn this into a sawtooth by taking the sine of the sine wave. And then I guess I actually need to do this here. And then we like add an offset. Let's see, row offset. That might be a, I might not have to use a sine actually, because let's see, maybe we could just, instead of taking the fraction, we would just take the floor of this and then multiply by the row offset. Yeah, I think that'd be easier actually. I mean, this doing the sine wave will work fine, but so floor. And then multiply by the row offset. And then we need to add that back in here. I guess I'll just form a vector 2 in case I want to ever mess with the y. Okay, and again, I'll clean this up later. So I need to add this. I think I need to add it back in here before I take the fraction. And then if I don't think that works. Oh, well, this should be the y. Okay, yeah, there we go. That's what we wanted. Now, is this offset? Oh, I was gonna say, yeah, I think it's a percentage of the brick dimensions and not like an absolute position, but I mean, I think that might be okay. Okay. Well, I mean, that's the basic of doing bricks. I mean, there's probably an easier way to do this than using a box SDF. I mean, you could just do a checkerboard, but this way works. What I would do to finish this off is obviously we need to add color, and then I would add a noise, like a noise texture, just to add some roughness to it. And then we basically made a height map here, so you could turn that into a vector for the normal pretty easily. But unfortunately, I do have to leave tonight, and I'll probably have to finish this tomorrow for the video, so it won't be on stream, but next week on Wednesday, you'll be able to see it on YouTube. All right. But anyway, thanks everybody for coming by and watching another pretty math-heavy stream, but I hope it was fun to watch. I always like working with SDFs. There's just something cool about them, I think. But yeah, so I'll put some links in the chat. If you enjoyed the stream, feel free to follow me on any other social media. I try to be pretty active on my Discord, especially. If you're new here, I go live and do game development every Monday, Wednesday, and Friday at 9 Eastern time. So I'll be back Friday, and then I upload a game development tutorial to my YouTube channel every Wednesday at noon Eastern time. So if that sounds interesting to you. But Yeah, thanks NTT and everybody else for coming by, and I'll see you Friday. Have a great night. Bye-bye.